All right. Well, happy to talk to you all tonight. I'm Dr. Chad Hanson, forest and fire ecologist with the John Muir Project. And I'm going to be talking to you tonight about forests and wildfires, climate change, and logging, and what it really means to keep the carbon in our forests. There's a lot more information on this if people want a deeper dive in my book, Smokescreen, Debunking Wildfire Myths to Save Our Forests and Our Climate. And in the book, I explain in great detail. I wrote it for non-scientists, but I have hundreds of scientific citations in the endnotes for people who want that additional background. And I explain why it's not just helpful, but essential to increase protection of our forests from logging in conjunction with getting away from fossil fuels in order to overcome the climate crisis. All right, so I'm going to talk about these issues in a few categories that are all interrelated. One is, does so-called fuel reduction logging reduce severity in wildfires? One of the big things we hear all the time is that we need to reduce wildfire severity because wildfires are taking the carbon in our forests and putting it all in the atmosphere. That's not true. There's a grain of truth to it, but it's mostly the opposite of that, but I'll explain why. So for starters, the entire notion that denser forests burn more intensely has been debunked in study after study after study. The largest, most comprehensive studies are finding that forests with more mass, more carbon, denser forests actually tend to burn at lower intensities when wildfires occur. Now, why is that? Well, it's because they have a cooler, more moist microclimate because there's more trees and more carbon. There's more shade because of the additional trees, more ambient moisture in the air, more relative humidity because of those trees and the shade and the canopy cover. And the denser stand of forest acts as a buffer against the winds that drive the flames. I apologize for some of the outside noise. I'm on the road coming home from a day in the field, and I'm stopping at a place with some Wi-Fi in Bakersfield to talk to you tonight. So apologies if there's a little bit of ambient noise in the background.
You're good. Right. We don't hear it.
Good deal. So this figure here, that's from Zalden Dunn 2018. But as I mentioned, there's also numerous other studies from independent scientists, from U.S. Forest Service scientists, finding the same thing, that denser forests tend to burn, all things being equal, they tend to burn at lower intensities, not higher intensities. And the same thing is true with forests that haven't burned in a very, very long time. The narrative out there that we hear from the logging industry and from federal agencies that are involved politically and financially in commercial logging, like the U.S. Forest Service, the narrative out there is that if forests haven't burned in a long time, they're going to be too dense and they're going to burn much more intensely. That's not true either. Turns out, if forests haven't burned for a very long time, they actually burn at equal or lower intensities when wildfires occur. And that TSF at the bottom there on the x-axis, that just means time since fire. So the column on the right is forests that haven't burned in the longest period of time, more than 75 years since the last fire. And that black line at the bottom, that's the percentage of high intensity fire. And you can see that that's pretty small in the areas that haven't burned in over 75 years. Mostly you see the light gray and the medium gray, which is low and medium intensity fire, where most of the trees survive. And so forests do not burn more intensely if they haven't burned in a long time. This is a nice finding from Forest Service scientists, Les Meester-Dahl 2021, and they found that more open forests with lower biomass had higher fire severity because those types of forests, including those resulting from thinning, have, quote, hotter, drier, and windier microclimates, and those conditions decrease dramatically over relatively short distances into the interior of older forests with multi-layer canopies and high tree density. In other words, lower fire intensity when there's higher tree density and more biomass. And I know that seems counterintuitive just based on everything we keep hearing in the media. We keep hearing that our forests are overgrown and that's why they're burning too intensely. And that is absolutely not true. That's mythology. And it's dangerous mythology because we need to keep the carbon in our forests and we need to protect our forests so they can absorb more of the dangerous excess of CO2 in our atmosphere and increase their carbon storage. Because the fact is, is that most of our forests have a lot less carbon in them than they naturally would have because of 150 years or more of logging and carbon removals. So as a result, they are way below their biological carbon storage potential. All right. And one of the key misconceptions out there is that, again, our forests are overgrown and that's why they're burning more intensely. But the reality is that it's not even about the density of the forest mostly. It's about the weather and the climate. Wildfires are driven by weather and climate change. If it's a drought year and it's hot, dry, windy conditions, or hot, dry, windy conditions coming on the heels of a long heat wave like we're seeing right now, you are going to get larger fires and faster rates of spread simply because of the weather. That is the dominant factor. Now, denser forests act as a buffer against the extreme weather driven by climate change, and they will slightly modify and tone down wildfire behavior because of that microclimate that I mentioned a moment ago. But if you have those hot, dry, windy conditions, any stand of forest can burn and burn even at high intensity if the weather's right, because again, it's driven by weather. So I studied this issue in one of the biggest fires in recent years, the Creek Fire of 2020. And this was a 380,000 acre fire in southern Sierra Nevada. And I found that the areas that had been logged in previous years actually burned more intensely when the fire occurred. The percentage of high severity fire was higher. And these areas, these were logged under the guise of fuel reduction. There was post-fire logging, removing the dead trees from earlier fires. There was so-called thinning, where they removed most of the live trees, including many of the mature trees, and reduced the canopy cover. And those areas tended to have actually higher levels of fire severity, not lower. And whereas the general forest lands, which didn't have any logging, and also the forests with no logging and just previous wildfire, had lower levels of fire severity. And this is what a lot of those forests look like in the Creek Fire, that were very, very, very dense and burned at low intensity. They looked like this. This is really common because, again, it's about the weather, it's about the climate, it's about climate change. It's not about the forest density. And to the extent that forest density matters at all, it actually has a mitigating effect, not an exacerbating effect. Whereas, in stark contrast, many of the areas that had been thinned under the guise of reducing forest density to curb wildfires, those areas actually burned like this. And you can see the stumps from the earlier thinning, very, very open forest, and it burned very, very intensely because, again, the winds can sweep through faster and it's desiccated because there's less canopy cover, it's hotter, it's drier, it's windier, more conducive to more intense fire. Another example, very, very open forest from earlier thinning. You can see the stumps from the earlier logging operation. You can see how open the forest was, and this burned at very high intensity, 100% tree mortality. There are many areas like this in the fire. Now, of course, just because it was thin doesn't mean it's always going to burn at high intensity. A lot of those areas burned at low and moderate too. But on average, they tend to burn at equal or higher intensities, those thinned areas, more open forests. And let's not forget, the thinning itself kills a lot of trees. It often kills most of the trees in the stand. And so that's an additional form of mortality on top of the wildfire that has to be taken into account. The Forest Service, most of the Forest Service studies don't even take into account tree mortality from thinning, which is a huge source of bias. And of course, when trees are killed, removed in the forest by thinning, they stop sequestering carbon because they're not alive anymore. And most of the carbon in trees that are removed from forests by logging operations end up in the atmosphere almost immediately. Very little ends up in a 2x4. The branches, the treetops, the bark, the round parts, the mill residue, everything that's not usable for lumber is burned typically in biomass plants and sometimes at the mill itself for dirty energy, climate polluting energy. And so only about 20 or 30% typically of the carbon in a given tree ends up as lumber. And so this is a bad proposition from a climate change standpoint, logging, and especially logging supposedly for fire risk reduction. This is an area that had been thinned for 40 years on private land in the Creek Fire. And then, of course, after the fire burned at high intensity, this is Southern California Edison land, they logged it through an intensive post-fire logging operation. And that's what you can see happening here, even more carbon removed. Same thing on national forest land. So this was an area that burned in an earlier wildfire, was post-fire logged, prior to the creek fire by the Forest Service and then burned at high intensity.
Stop it.
All right. So let's see. We looked at this issue in terms of cumulative tree mortality from thinning plus wildfire, and we found that the overall tree mortality, thinning plus wildfire, what we call cumulative tree mortality or cumulative severity, was significantly higher than it was in just unthinned forests that were just wildfire. And that's an important finding because, again, this is all sources of tree mortality, and it's not just tree mortality from thinning, it's tree removal and carbon release into the atmosphere. Whereas in the fire, it's just tree mortality and the carbon is retained in the forest because dead trees still have almost all of their carbon. Now, this is an image from the Caldor fire of 2021. This is the western side of it. And all those black polygons, those are areas that were thinned. And you can see that the fire burned very intensely through the thinned forest and the unthinned forest. It didn't change the fire intensity. Yeah, the thin forest burned just as severely as the unthinned here. And it's because the weather was extreme on that day, very hot, dry, windy conditions. And that's what drives fire intensity. So my colleagues and I published a study a couple of years ago in Biological Conservation, big literature review on this issue. And one of the things that we did is that we really debunked a trio of U.S. Forest Service articles that omitted massive amounts of evidence and cherry-picked evidence in order to promote the idea that we need to log our forests supposedly to curb wildfires. And the amount of evidence to the contrary that they omitted was really quite shocking. We published a larger study that found that well, first of all, that even some of the studies they cited admitted that thinning oftentimes increases fire intensity. And these are some of the quotes from those studies that they cited. But then inexplicably concluded that thinning is very effective to curb wildfire, even though they admitted many studies find the opposite. And then we published a larger study documenting how much evidence they had omitted that found the opposite. And interestingly, forests with more dead trees do not burn more intensely either. That's a common misconception, that if you have a lot of dead trees, the forest will burn very intensely. And it turns out that that's not true either. Dead trees just don't have much to burn. Soon after they die, the pine needles drop to the ground, the small twigs drop to the ground. They very quickly decay into soil, and there's just not a lot to carry flames. Mostly what carries flames are the pine needles and the small twigs. Dead trees don't have that beyond a couple of years. And let's see. And I found the same thing in my research on the creek fire. Forests with more dead trees per acre or per hectare didn't burn more intensely. There's no relationship there at all. And in fact, when dead trees fall, much more than being fuel on the ground, they act like giant sponges. They soak up and store 25 times more water per cubic foot than the surrounding soil. And so they're really reservoirs of water in the forest more than anything, and carbon. And my colleagues and I conducted a 4.5-year intensive field study of two of the biggest fires in the Sierra Nevada over the past 20 years. We found that less than 2% of tree carbon is actually consumed and emitted into the atmosphere, even in the biggest fires. On average, we found 1.2%, actually, 1.2% on average. And whether trees are alive or killed, there's just not much carbon. Not much carbon is actually consumed and emitted. Thinning, in stark contrast, emits at least 3 times more CO2 into the atmosphere per acre than wildfire alone. So it's a big climate change impact. And the main reason is that, of course, most of the carbon in the trees is incinerated, released into the atmosphere, and only a small percentage ends up as stored carbon temporarily in a lumber product somewhere. And this is a figure that just kind of illustrates that. All right, I'm going to talk very briefly here about the second part. Does high intensity fire destroy forests? The answer is no. It's actually really, really important. The heterogeneity from these fires creates great habitat. Even the biggest fires are mostly low and moderate intensity, but there is always a portion of high intensity that's not just natural, it's essential, because it turns out there are many wildlife species that have evolved to depend not just on post-fire habitat, but on high-intensity areas where the fire kills most or all the trees. Blackback woodpeckers, many shrub nesting birds, many cavity nesting birds, including bluebirds. And so historically, before fire suppression, typically any given fire on average would have anywhere from 20 to 35% high intensity fire. And sometimes lower, sometimes higher. And we also found in our research that forests were much denser historically than the Forest Service scientists have been telling people, because they've been omitting vast amounts of historical data that we found in the National Archives and corrected the historical record. When we included all the trees they omitted, when we included all the historical Forest Survey data that they omitted, data collected over a century ago by the early US Forest Service researchers, we found that historical mixed conifer forests were 7 times denser than the Forest Service reported in terms of trees per acre, and historical ponderosa pine forests were 17 times denser than they reported. That finding is unrebutted and unchallenged in the scientific literature. And there was lots of high intensity fire. Fires were mostly low and moderate, just like they are now, but there were significant amounts of high intensity. Those white crosshatch areas, those are high intensity fire patches that occurred during the 19th century and 1800s, over the course of a century. And you can see some of those patches are quite large. These are thousands of acres in size. Some of them are actually tens of thousands of acres in size. And some of them could be close to multiple patches over the course of a century. But the point is that there was significant spatial coverage at times of high intensity fire. And this is what that habitat looks like. We call it complex early seral forest. It's also known as snag forest habitat. And this is all the rich natural regeneration, the fire-killed trees, what we call snags, incredibly important for wildlife, especially cavity nesters, and all the natural regeneration, which of course is carbon sequestration and storage. That's all the forest pulling CO2 out of the atmosphere and storing it in the growing, regenerating forest after the fire. A lot of the denizens of the snag forest habitat that depend on the high intensity fire areas, blackback woodpecker at the top there. They depend on the native wood-boring beetle larvae that use the dead trees, the wood-boring beetles, to reproduce. They can't reproduce without recent fire-killed trees. And the blackback woodpeckers eat thousands of the larvae of these native wood-boring beetles every year and excavate nest cavities in the dead trees, which are softer than live trees. And then, of course, they don't reuse their cavities. They create new ones all the time. And so the ones they don't use anymore are available for bluebirds and nuthatches, flying squirrels and chipmunks, and lots of other cavity nesting species in the forest that have to have tree cavities to reproduce and raise their young, but cannot make their own tree cavities. They need blackback woodpeckers, other woodpecker species, to do that for them. And in fact, what we find is that total bird abundance is often highest in forests that burn at high intensity. And that may seem counterintuitive, but again, these are ancient processes. Mixed intensity fire goes back not just thousands, not even just millions, but tens of millions, and even hundreds of millions of years in evolutionary history. So it's a deep evolutionary history. Lots of plant and animals have evolved to depend not just on fire, but on post-fire, but on high intensity fire specifically. And this is me and Dr. James Hanson, a climate scientist, and a field visit together in the Rim Fire, looking at areas that the US Forest Service claimed would not naturally regenerate because they burned at high intensity. And of course, they were all naturally regenerating just wonderfully. Lots of regeneration, lots of carbon sequestration after the fire. And right next door, the same high intensity fire patch, this was an area that was post-fire logged and artificially planted by the Forest Service under the guise of post-fire restoration and reforestation. You can see there's a very small number of seedlings that survived here. If you look closely, you can see some. But mostly what you have is just a stump field, bare ground, and invasive grasses that were spread by the logging machinery. And of course, almost no carbon left whatsoever. This is a photo that I took at 8 years post-fire in an area that was in the interior of one of the largest high-intensity fire patches, the Rim Fire. You can see all the amazing natural forest regeneration, and all the carbon storage in the snags, and the carbon sequestration in the regenerating forest. So This is the same high intensity fire patch once again, juxtaposed. This was post-fire logged and planted under the guise of post-fire restoration and reforestation, and you can see the result. Now, of course, they oftentimes will come in and plant again, and some of those trees will survive. So it's not like it looks like this forever. But what I will say is that the amount of carbon storage is vastly lower because the snags are gone, the dead trees, they removed them, that carbon is gone from the system. And the damage they've done to the ecosystem with the logging machinery and the removal of trees is so significant that it really stunts the growth of whatever they plant. And so you have far, far less forest carbon storage and far less sequestration. And I'm finding the same thing. Our team of researchers is finding the same thing in giant sequoia forests. When they burn at high intensity, they regenerate by far the best. Turns out giant sequoias are very, very specially adapted to regenerate best after high intensity fire. Now, low intensity is natural too, so it's moderate, but they don't effectively regenerate after low and moderate, only after high intensity fire. So that's their natural life cycle. These are all giant sequoia seedlings in the foreground there, and you can see them in the background too. And so, there was a recent U.S. Forest Service paper that claimed that 30% of the conifer forests in the southern Sierra Nevada have been converted to non-forest since 2011 by fire and beetles. The researchers never left their offices and actually went to these forests to find out if that was true. They didn't gather any field data. They used a hypothetical model to draw this conclusion, which I think folks should be very skeptical of. And this is an example, example after example after example of places that they claimed had been converted to non-forest by fire or beetles, where in fact most of the trees were alive and just fine, and the forest was regenerating wonderfully. And so this was basically either a massive error, an innocent one, but a very profound error on the part of these Forest Service researchers, or in the worst case scenario, deliberate attempt to mislead. And I won't make that assumption. I try to assume the best of people in terms of their intentions, but at a minimum, it was a result of gross incompetence and was wildly inaccurate scientifically. All right, so I'm going to stop screen sharing there, and I would be happy to answer any questions. Yeah, Sheila. Okay.
We had some questions on the chat.
Okay, let me pull those up. Yeah, okay. So first question, has California accepted my finding if the sample size is sufficient? Let's see, sorry. It seems like the results would be beyond dispute. Yeah, it's interesting. Some have accepted our findings and others have not. But again, we've tested these in multiple studies. Other researchers have come in and tested and found the same thing. So even Forest Service scientists, for example, looking at whether forests burn more intensely if they haven't burned in 75 years or 100 years. Forest Service scientists said, well, we couldn't possibly be right. That's so counterintuitive. They tested, they found the same thing we did. Forests that hadn't burned in a long time that tend to be denser actually had lower fire intensity. And that's the Miller et al. 2012 study. They found that. And so there's a lot of science on this. The problem is that it runs counter, the science, mine and others, runs counter to political and economic goals of many state and federal agencies and many industries, including the logging industry. And that's part of the problem, is that there's a lot of money being made in business as usual. And so that's one of the things we're fighting against. Having said that, there is a growing number of even U.S. Forest Service scientists breaking ranks and finding the same conclusions that we are, like the Lesmeister et al. Study. Let's see, another question here in the chat. How much climate change temperature will convert forests to meadows? Yeah, that's a good question. Obviously, if we don't get a handle on climate change, we're in trouble on multiple levels, right? As temperature continues to rise, it's going to impact ecosystems in myriad ways. One of the things I put out there a lot, because I think this is key, is that we need to have separate conversations about the impacts of rising temperatures from climate change, which has its own impacts that are impacts unto itself, versus wildfire, which might increase because of climate change. And I believe it is increasing. It's still in deficit in forests, by the way. We do not have too much fire in forests. We have less than natural, but we're getting closer to natural levels. But what I'm finding in my research, and I'm doing a lot of research on natural post-fire regeneration, is that if anything, wildfire is conferring resilience in these forest ecosystems in the face of climate change. These systems are regenerating in abundant fashion in these high-intensity fire areas in the era of climate change, including during droughts, including the lower elevation ecotones that are most climate stressed. So why is that? I don't know for sure. What I can tell you is what we're finding is good news. I wish I had all the answers as to why, but the why is always harder than the what. What I think is happening is that, again, this is ancient evolutionary history. These are deep evolutionary processes, and the range of genetic variation is incredibly high. There's a lot of regeneration after fire, natural regeneration. Every one of those little seedlings has has its own fine-scale genetic variation. Some of them are more adapted to the current climate, and some of them are not. The ones that aren't die. The ones that are survive, and those will become the next generation of forests that are more adapted to this current climate. That have that genetic variation that comes from a period in time in the deep evolutionary history that was more similar to what we have now. So I think that's what's happening. It's good news. I see another question. I was recently in Sequoia National Park, noticed very few young trees. Is that due to no high intensity fires? Yeah, it is. It's interesting. In giant sequoia groves, and this presentation isn't about giant sequoias in particular, but it's an important question. So I'll try to answer it quickly. In giant sequoia groves, we have been successfully excluding wildfires for over a century until recently, until about 2015. There have been a series of natural lightning strike wildfires since 2015, especially in 2020 and 2021, that have burned most of the area in these giant sequoia groves since then. So like most giant sequoias groves have burned since 2015. They've been 87% low and moderate intensity, only 13% high intensity. But you get a little bit of regeneration in the low and moderate, mostly in the moderate, a little bit, that survives and is growing at a moderate rate. But you get amazing regeneration in the high intensity. And so, yeah, in answer to your question, it really is because of the lack of higher intensity fire that we don't see many young giant sequoias in these groves. You see these, these large giant sequoias, these monarchs, 8, 10, 12, 15 feet in diameter, maybe 2 per acre, typically, and almost no young ones. The truth is these giant sequoia groves have been slowly dying for over a century because we've been loving them to death, thinking that we were helping by keeping fire out of the groves, or by imposing homogeneous low-intensity surface fire on the groves, superscribed burning, thinking that would save them from high-intensity fire. And the reality is that's actually an extinction strategy. They need the mix of fire intensities, and they need that higher intensity fire to occur at least every few hundred years. And that's what they've been missing. Now they have it, and we've got a whole new generation of giant sequoias. I see Eddie has a hand up. Go ahead.
Yeah, hi. First of all, we were talking before you got here. I'm a fire captain for a municipal department here in Fallbrook. I've experienced going to these fires on strike teams and things, but I'm not an expert in the forest at all. So a couple questions. First of all, it was in the chat, but I think it's a really good question. How do you measure a high or define a high intensity fire?
Yeah. So I use the term intensity in place of severity because I'm really sensitive to the fact that there's a lot of pejorative terms in wildfire issues that actually drive bad policies: catastrophic wildfire, severe fire, high severity fire. So I use intensity because it's a neutral term. In technical terms, when I publish studies, I use the term severity because it's a term of art. Severity is a function of tree mortality. Intensity is a function of energy release. The truth is, though, they're highly correlated. And so if it's high intensity, high energy release, typically it's associated with very tall flames and killing most or all the trees. So the standard definition for high severity fire, which I synonymously call high intensity fire, is 75 to 100% tree mortality. and moderate is 25 to 75%, low is less than 25%. That's a standard definition. Sometimes the definitions vary slightly, but that's generally it. And so in a high intensity fire patch, you won't always have 100% tree mortality. Sometimes it's closer to 75%, but it's definitely, you know, on average, it's usually 85 or 90% tree mortality. And, you know, it turns out that that's actually incredibly good habitat. So it's not a bad thing. You know, you don't want it too much or too little of a good thing, right? You know, so the question is, are we within the natural range of variability? Good news is, even though we're getting closer to natural levels, we still have a deficit in our forests of all levels of fire intensity, low, moderate, and high. So if we have a big fire year, it's not a bad thing because we're still in a deficit situation. We don't want to overshoot the range of variability, but I don't think we're going to do that. We're nowhere close right now. I see there's a question about Redwood Canyon area in Sequoia National Park. I have a lot of information about Redwood Canyon. If you want to look up this, you can go into Google Scholar and search my name and search giant sequoias and high severity fire. And you will pull up free PDFs of two of my recent peer-reviewed studies. One of them that was done in the large high intensity fire patch in Redwood Canyon and in Kings Canyon and Sequoia National Park, and adjacent low and moderate severity areas. And the other one, which was done in the Nelver Grove on Sierra National Forest. And you'll see we found that the best regeneration by far, the tallest, most abundant, et cetera, is happening in the higher intensity fire areas. Let's see. And question about chaparral. Really glad you asked that. You know, so as I mentioned, we have a deficit of fire in forests. We do not have a deficit of fire in Southern California chaparral or in chaparral in California in general, but especially in Southern California. We actually have too much fire in Southern California chaparral. Partly that's because of climate change, but the big factor is just unplanned, accidental human ignitions. Once in a while, arson, but usually accidental. It's just, you know, a lot of people next to the chaparral doing things during fire season that cause ignitions accidentally. I believe one of the solutions here is just more monitoring. We just need more people on the ground at county, state, federal levels to prevent unplanned human ignitions in chaparral so we can bring things back into balance and get back in within the natural range of variability. Because in Southern California chaparral, we actually are in excess of the natural range of variability on the high end. Like I said, fire's natural. It's natural in forest. It's natural in chaparral, but you don't want too much and you don't want too little. We have too much in Southern California chaparral right now. Let's see. I think that was all the questions in the chat. Oh, Eddie, I see you have another question. Go ahead.
Yeah, I was actually going to stay away from the non-forest fires, but follow up on the last point. Do you think that increased chaparral depth is correlated to higher fire intensity in Southern California, or is it like forest where it kind of, the thicker it is, the more it snuffs it out? Do you have any opinion on that?
Sure, I do. In fact, my colleagues and I published a book in 2015 called The Ecological Importance of Mixed Severity Fires, Nature's Phoenix. It's a science textbook, but we wrote it to be fairly accessible. There's a whole chapter on chaparral and fire and debunking some of the misconceptions about chaparral and fire. Chaparral burns naturally, almost exclusively at high intensity. So that's its natural thing. So it's not a matter of chaparral burning more intensely. There's no such thing as, you know, low intensity chaparral surface fires. I found a couple of patches, like 1/10 of an acre here and there, in really, really old growth manzanita. But basically, it's an extreme rarity and it's almost 100% high intensity. That's its natural pattern. So the question is there just too much fire? And the answer to that is yes, in chaparral, there's too much. In that chapter in our Nature's Phoenix book, we debunk my colleagues, because I'm a co-author and editor of the book. I didn't co-author every chapter. My colleagues, including Rick Halsey, who's an expert on chaparral and fire, debunked this notion that older, denser stands of chaparral will burn more intensely. That's not true. And that misconception has led to a lot of mismanagement and a lot of damage to Southern California chaparral that I've seen, including cutting old growth manzanita, including mastication and chipping of chaparral, where what you typically get, you replace, you know, mature and old growth chaparral with a bunch of wood chips on the ground, which are highly flammable. And you typically, the machinery usually spreads cheatgrass and other highly combustible invasive grasses that spread flames faster. And it just doesn't provide any real benefit. So as a landscape management activity, it's a terrible idea. You don't want high accumulations of chaparral within 30 feet of your house, but that's not about ecology. It's just about protecting your house. There you've got to do something for defensible space. But out in the wildlands, just, leave the chaparral alone, leave the forest alone. They're doing just fine on their own, as long as fire is within the natural range of variability. And with chaparral, I'm actually in favor of fire suppression because we have too much fire. In forests, I'm not. Tom, I see you have a question.
Yes, thank you. Well, I've learned so much about fire myths in the last half hour, but I grew up in the Smokey the Bear era. Is making fire breaks through forests a good idea or a bad idea?
It's a bad idea on multiple levels. I'll explain why. Number one, first and foremost, most importantly, they do not work. They don't work. They don't work in chaparral. They don't work in forests. And it's not to say that like a fire never stopped at a fire break somewhere. Of course it's happened, but it's usually a fire that would have stopped, around that area anyway, just because the weather changed or the wind shifted in direction. What we find is that when so-called fire breaks are created, what generally happens is the relatively less combustible vegetation is removed, generally trees and mature chaparral, and that is replaced by relatively more combustible vegetation, which is usually invasive grasses brought in by the machinery that's removed that removed the trees and the mature chaparral. On top of that, the fire break undermines the microclimate that a denser stand of forest has. It creates hotter, drier, windier conditions that spread flames more rapidly on top of the highly combustible invasive grasses that it spreads. And on top of that, fires oftentimes don't just spread by the flaming front. They spot in advance of the flames and then leapfrog over and over and over again with flaming embers driven by the winds, hundreds of meters in advance of the flames, sometimes kilometers in advance of the flames. And of course, there's no fuel break you could ever create that will be wide enough to stop those embers. The Eagle Creek fire, for example, in Oregon, jumped the Columbia River Gorge, which if any of you ever been to the Columbia River Gorge, you understand that that's massively wider than any fuel break you could create. And the fire had no trouble whatsoever jumping over the gorge because, again, it was leapfrogging with embers. And so in the Dixie fire, we saw embers leapfrog 8 miles. 8 miles. So fuel breaks don't work, but that's one reason. The second reason, they're ineffective. The second reason is I actually believe they're not just ineffective. I believe they are actually counterproductive and actively harmful. I say this for a few reasons. Number one, they tend to spread flames faster. Whether they burn more intensely or a little bit less intensely, fire will move faster through a fuel break because there is less of a windbreak, because most trees have been removed and because it has a hotter, drier, windier microclimate. What that means is, because a lot of these so-called fuel breaks are kind of amorphous in size, they're large, sometimes they're quite wide, half-mile wide or more, the fire will spread faster toward a town, giving people less time to evacuate safely with themselves and their animals. That sometimes has tragic consequences, and we have seen significant loss of lives recently because people did not have enough time to evacuate. That's exactly what happened in Paradise in the Camp Fire in 2018. For example, and it's not the only example, Camp Fire in the first fateful 6 hours spread by far its most rapidly of any time during that fire, which burned for weeks, by the way. It burned vastly faster in those first 6 hours, which happened to burn through the most heavily logged areas in the northern Sierra Nevada, where many thousands of acres, probably thousands of dead trees, probably millions of dead trees and live trees were removed across thousands of acres in between the point of origin and the town of Paradise in the years before the fire, under the guise of a fuel break to protect the community from fire. The community was told that this fuel break will stop a fire or make it drop to the ground as a low intensity creeping surface fire that will be easily suppressed and put out. That is not what happened. Instead, it burned very rapidly, very intensely through that fuel break, raced to the town, killed 86 people, and burned down 14,000 homes. That was preventable. That was avoidable. And so the third thing is it's giving communities a dangerous false sense of security because they're being told by state and federal agencies, the U.S. Forest Service, by CAL FIRE, by logging companies, they're being told that these so-called fuel breaks out in the wildlands will save them from fire. Now, what's happening in these communities, a lot of them are working class residents. They don't have a lot of money. It's a big deal for them to spend a few $100s and hire someone to do defensible space pruning within 60 or 100 feet of their home. It's a big deal for them to hire someone to sweep the pine needles off the roof. Excuse me. I lost my earphone. Some people in the communities have the resources, some people have the physical ability, but there are also people who are older and don't have the physical ability to do that, and they don't have the money to do it, or it's really tight, and it would be a big deal for them. So what is happening is a lot of these folks are foregoing that work. They're not doing the defensible space work, even if they potentially could. It might be difficult. They're not doing it because they're being told that these fuel breaks have them covered and the fire won't reach the town. That is a dangerous lie that's been proven to be false again and again and again. 2018 in the Camp Fire burned down Paradise. 2021 and the Dixie Fire burned down the town of Greenville. 2021, the Caldor Fire burned down the town of Grizzly Flats. 2020, North Complex Fire, Berry Creek, among others. 2007, the Grass Valley Fire in Southern California in the San Bernardino Mountains burned down the Grass Valley community west of Lake Arrowhead. In every case, they had done these logging projects under the guise of fuel reduction and fuel breaks, and the fire raced through those areas, burned down many, many homes, and in some cases killed a number of people. And so it's exactly the wrong way to go. What I advocate is protecting the forests from logging, including any logging under euphemisms like thinning, fuel breaks, restoration, forest health. There's a whole parade of these deceptive euphemisms, and instead redirecting those resources into a jobs program, state and federal, to create fire-safe communities, especially for residents that need the help and want it. Home hardening, making homes more fire safe, lots of easy and safe and effective ways to do that, and defensible space pruning, as well as evacuation planning and assistance. That's where we need to go, directly helping homeowners, directly helping communities become fire safe and stay fire safe. Yeah, Dale. Oh, you're on mute. You're on mute. I can't. Dale, you're on mute. I can't hear you. There we go.
Oh, I'm sorry.
That's all
right. Is regeneration after high severity fire or fires temperature dependent over the long run? Because if we're headed into a warmer climate, is regeneration going to slow or speed up?
That's a good question. I don't know. I really don't know. What I can tell you is I published a couple of studies recently on natural post-fire forest regeneration, actually several papers recently, on natural post-fire forest regeneration that just happened to occur during some of the most severe droughts, hottest summers. And we found abundant natural forest regeneration, really pretty remarkable. Now, this is why I say we need to disentangle the conversation about rising temperatures from climate change and wildfire, because I believe wildfire is actually allowing these forests to persist in these areas in the face of climate change. However, if we do not get a handle on climate change, rising temperatures will make some of the lower elevation forests inhospitable for forest habitation. It simply will. It'll just become too hot for forests to persist in those areas. Now, I believe that that's not going to happen because I'm an eternal optimist, and I believe that we will, not right now, because we're still doing all kinds of stupid things, as a society. But I believe we will, over the next 20 years, turn the corner on climate change. And we really will massively reduce our emissions and also essentially substantially and dramatically increase protection of our carbon sinks, especially forests, from destructive activities like logging. And I believe that's going to happen. So I believe that we will moderate temperature rise. If we do not, it will have massive impacts on ecosystems. There's no getting around that. And human societies, sea level rise, coastal communities, there'll be lots of problems. But I don't think wildfire is a problem. What I'm seeing is wildfire is actually conferring resilience in these systems, allowing them to perpetuate and thrive. Probably partly because of the nutrient cycling. It's a big factor in wildfire. Phil.
Thank you. The last time I watched congressional hearings with the U.S. Forestry Service chief, it seemed like what they were espousing was 180 degrees opposite of what you and John Muir Society advocates for. And the senators of many states were getting the full endorsement of the U.S. Forestry chief in all these logging programs. You know, we'd love to log this in this state and log that.
Yeah. And
the Forestry Service says, I'm going to assign these people to make sure you can log every last section that you need to log. We're going to defeat this. Right. And I thought, but what's going on with Congress? How could they be so far misled by the United States chief of the fire department for the forest? It doesn't make sense.
Well, listen, it's a really important and complex question, and the answer is complex. I'll do my best to give the 60-second version. 60-second version is it's a mix of fear, misinformation, and greed, almost in equal fashion. The Forest Service is very much in the business of logging. They're highly incentivized to continue business as usual, to ignore contrary science, to misrepresent science, to omit science that contradicts their management paradigm, which is to log as much as possible and call it benign, benevolent sounding things like forest health, fuel reduction, restoration, etc. It's very much in their financial interest, not just because they sell public trees to private logging companies and keep the revenue for their budget, which they do, but also because the more they log, the more money they get from congressional appropriations right out of taxpayers' pockets. Frankly, I think that's the biggest perverse financial incentive right now. Billions and billions of dollars every year. So they're getting money coming and going to them the more they log and call it, restoration, fuel reduction, etc. The chief of the Forest Service knows this, but we have to understand that he is a political appointee, and the statements he's making to Congress are political statements, not scientific statements. The statements he's making are absolutely not true. They are contradicted by most of the peer-reviewed published studies, especially the most comprehensive studies. And we also have to understand, and again, this is not me being cynical, it's just understanding, what we're up against, and so we can effectively deal with it, that many members of Congress get campaign contributions from various aspects of the logging industry, and not always lumber companies. Sometimes it's timber industry trade associations. Sometimes it's the forest biomass industry, which is really dangerous. Sometimes it's other kind of subsidiary elements. Sometimes it's the home builders that are just kind of one step removed from the logging industry. And you can go on Open Secrets and search your member of Congress and search your U.S. senators and find out, and you can send them, you can engage them on social media, you can send them emails, you can send them letters, you can make phone calls to their offices and ask them why they're taking money from various aspects of the logging industry and ask them to stop. Now, many Republicans are taking this money, but also many Democrats. And some of them are kind of obvious. The centrists were more conservative Democrats, but some of them would surprise you. There's some pretty progressive Democrats that are saying all the right things when they make speeches to their constituents, the things people want to hear. They care about climate change mitigation. They care about ecosystems. In reality, they're taking a lot of money from logging interests and they're promoting some really bad policies. They need to be held accountable. Democrats and Republicans, I don't care who they are. I'm very nonpartisan in my views. I just care about the issues and I care about biodiversity and turning the corner on climate change and protecting communities, all of which, in my opinion, dovetail on a single solution and basically means, kind of to use your phrase, we need to do a 180 turn from what we're doing and go in the opposite direction. Move away from all the backcountry logging, move away from all that backcountry removal of carbon from our ecosystems, from forests, from chaparral, instead redirect that money into protecting communities from wildfire, a place where we know we can do good, where we have stacks of scientific evidence that tells us exactly how to do it and that it's extremely effective. And we can save homes and we can save lives. And in the process, allow our forests and other ecosystems to absorb and store a whole lot more carbon and mitigate the climate crisis instead of removing a bunch of carbon from our forests and putting it in the atmosphere and making things worse.
Well, do you think the science community itself could prevail upon like the subcommittee on forest and it's under the auspices of Department of Agriculture. That's
Yeah.
Tom Vilsack. Wouldn't it be possible to focus in on the chief, Tom Vilsack, and say, well, here's the actual science and here's what's happening.
Yeah.
Can't we fix this?
Totally agree, and we're doing that. We had a letter from over 200 scientists, climate scientists and forest ecologists in 2020 to the administration, including Vilsack and members of Congress, making the points that I'm making to you today. We had another one in 2021, November of 2021, to them, making the same points. And it definitely, you got the attention of some folks. So I'm not, I don't mean to convey the impression that there are no members of Congress who are listening. There definitely are. And some are they're getting the message, and they are allies, and they are helping. They are not the majority, and we need to make it the majority. And that's really what it comes down to. We need to equally hold accountable anybody, whether they're Democrat or Republican. We need to hold them accountable if they're doing the wrong thing. And promoting the current management paradigm, because again, the stakes are just too high right now. The stakes are too high for communities that are at risk from wildfire. The stakes are too high for threatened ecosystems and species, and the stakes are too high for our climate. We just don't have the time to screw around anymore and keep making really dumb mistakes that the best available science will move us in the wrong direction. So, we have hundreds of scientists that are saying these things, myself included. And on the other side, there's a few dozen scientists who are funded by the U.S. Forest Service or the logging industry or both to say the opposite and spread misinformation. Some of them believe what they're saying. I think some of them they know very well what they're saying is false, but they do it anyway because the money's good. I think part of this is just making sure that policymakers, especially people of good faith who have just been misled and are not just bought off, making sure they understand that they're being snowed by a relatively small number of very vocal, highly funded scientists who are paid by essentially the logging industry. And by the way, some of these are university scientists who do not mention that they get $200,000-$300,000 a year from the Forest Service.
Wow.
One of the things we do is expose that as well.
Thanks.
Yeah, but thank you. I appreciate that. Yeah, John Muir Project is working on this every day, very hard, and we're doing a lot of work with a lot of our partners who are working tirelessly with John Muir Project to try to change the direction of this. I actually need to sign off.
Okay.
I am en route to home and need to get home for a number of things before it gets too late. But I really do appreciate the invitation to come talk to you tonight, and I appreciate all the really smart and thoughtful questions. And I'd be happy to do it again in the future if you're interested.
Thank you very much.
My pleasure.
Thank you very much. We'll be in touch if people have more questions in the future, and we'll get those.
Sounds
to
good.
you.
And
All
again,
right.
like I said, check out my book Smokescreen if you really want to do a deeper dive on this, and I'd be happy to give another talk on following up on that. Night, everyone.
All
Thank
right,
you.
good night.
Hi,
Great.
safe travels.